AB is 15. AB, 15. BC, C, 8. Angle B is 24. Once again, does it matter how I draw the triangle, or is it only there for illustrative purposes? Illustrative purposes. This is not the triangle. It just sets it up. Now you have, I wonder who they will need for Mr. Fujimura's class today. Go for Myers. Hey. Yes, I will. Bye-bye. They found the right class. Jordan Fogarty. Take the long and lonely stroll down to the office. I would consider taking my stuff were I you. Now, oh no, it's labeled weirdly. This is little b. But, everybody take a deep breath. We're looking for this side, aren't we? Are we in charge of this question? Yes. Can we go ahead and call this side little c if we want? Yes, because we do not get bullied by math. We take math out back and show math what it's like, right? So if that's little c, regardless of anything else, this becomes little a, this becomes little b, and this becomes big C, and now we're in business, aren't we? C squared equals 15 squared plus 8 squared minus 2 times 15 times 8 times cos 24. And then at the end, you square root the whole thing. 225 plus 64 minus 30 times 8 is 240 cos 24. And then you square root the whole thing to get, dun, 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 225 plus 64 minus 2 times, not 2, you doofus, 240 cos 24, close brackets, equals, second square root, second answer, close brackets, equals 8.35. Huh? Everybody good? All right. Anything else from over here? Number 7. Sure I can. Number 7, I don't need to do any pasting because I can see it. In a parallelogram. Hard to do this question if you don't know what a parallelogram is, isn't it? So, is this a math question or does this become an English question? It's also an English question, isn't it? So if you don't know what a parallelogram is, you had to do one of two things. A, look it up. B, skip the question. A parallelogram is this jobby, where these guys are both parallel to each other. Okay? So that's a parallelogram. The obtuse angle is 116. Which is obtuse? Angle A or angle B? Angle A is the obtuse angle. So we really only care about this part of it, right? So this is 116. What else do we know? The adjacent sides measure 40. Which one of these should I put the 40 on? The longer one. And here should be the 22, and there's my triangle. What does that make this side? Little c, and then I just fill in the formula. Okay? Anything else?
Can you do number 13?
Of course I can do number 13. I'm the math teacher. Oh, wow. The maximum width of Moondog. Well, where would the width of it be? It would be all of that, right? And that and that. I will use 3 different colors. What have I got? Blue. That. But that would be times 2, wouldn't it? Everyone agree? So if I know that distance, and I multiply it by 2, and I add that distance, I'm in good shape, right? Okay, so where do I have some numbers? I know the only distance, I should change color. The only distance I have is this, correct? I know that this is 33, this is 73, so do I know this angle? I do, don't I? What is it? Or wait, not what is it? How would I find it? The 180 minus. So, I need this right here, don't I? What do I know about 60, 60, 60? They're all the same size, right? So if I can find this, I know this, right? How will I find this? Well, I got 161, and I know this angle, don't I? Isn't that a sine law? And I have this angle, don't I? And I need that side, don't I? So if I sine law, I will get that, yes? Then what will I do with that answer? I will put it there, but I will multiply it by 2, because I have it twice. So I'm going to sine law to get that. Everybody cool? That's the easy one. The other one, we're in a bit of trouble, aren't we? So, what do we know? Are these two triangles the same? Yes. So what do I know about peachy line and peachy line? They're the same. What do I know about peachy angle and peachy angle? They're the same. Excellent. So, if I can find this angle, I would be in business, wouldn't I? This is 60. How big is this? 180 minus 73 minus 29, right? So it's 180 minus 73 is 107 minus 29 is 78, yeah? Everyone agree? So this is 78, correct? What is this angle? 180. 78 and 60 is 138, right? So what's this? 42. So what's this? 42. So what's this? 180 minus 84, 96, right? Everyone agree? So now I got all three angles. If I can find one of the sides, can I do trig? I can do sine law, right? Or, if I found that side, then I would know that side is the same, and I could do cos law, couldn't I? Your choice. I know this, so I know this. I know that, I know that. There is a sine law opportunity. Once I have that, I know that, and then it's a cos law opportunity. Everybody good? Again, I'm not going to do it because once you know when to use sine or cos law, you're just filling in the formula. Okay? The problem here is not sine law and cos law. They're easy. The problem is seeing how to get there. Right? And how do you get better at that? Practice, practice, practice. Anything else? I bet I can. Oh, 26. Just to make sure, I'm going to take 26 and do it on real graph paper. Okay? There's no graph paper there. There's no graph paper there. There's no graph paper there. Fortunately, I keep my feathers numbered for just such an emergency. Somewhere I have graph paper. Not there. Not there. Where could my graph paper be? Graph paper. Graph paper. Could it be in there? Could it be in there? Could it be not there? Graph. I found it. I know you all care. Print. Current section. No, not current section. I want it in pre-calculus 11. Trig. Okay. Pre-calculus 11. Trig. Okay. Now, can we fit it on this one? Paste. All right. So, let's graph -5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Everybody happy? Excellent. 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. B. Yeah? C. 2. 1, 2, 3, 4, 5, 6, 7. C. Extend BC to intersect the y-axis. So first I need to make this triangle. Sim sim salabim. And then that needs to extend to intersect the y-axis at D. And then, no more and then. Sweet. Okay. Extend BC. Find the measure of ABC, so this angle right here, that is the first theta I need. And then find the measure of ACD. This is the second theta I need. Yeah? Okay, so how am I going to do this? I need some distances, don't I? Okay, how am I going to find these distances? Pardon me? So, what Rena is saying is she knows all these coordinates, yes? So, from A to B, 1, 2, 3, 4, 5, 6, and over 5, 6, 7, 8, 9, 10, 11, right? -5, no, 13, right? So this was 6, this was 13, correct? Can she find this? How? Pythagoras. This is the square root of 6 squared plus 13 squared, correct? Everyone agree? Okay. Now, can she find this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And over 1, 2, 3, 4, 5, 6, 7. What's this guy? Square root of what? 121. 21 plus 49, right? That's a horrible pen to have used. This is the square root of 121 plus 49. Agreed? Everybody cool? Can she find this side? How? Pythagoras again. Up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this is the square root of 36 plus 25, right? Once you know all three sides, can you find an angle with cos law? Yes. Once you know that angle, can you do sine law to find that angle? Once you know that angle, how do you find that angle? 180 minus that one. Okay? Again, did I show you this? No, of course not. Why would I? Was there anything new there? Do you know how to graph? Yes. Do you know how to do Pythagoras? Yes. Do you know how to do cos law? Yes. Do you know how to do sine law? Yes. Do you know how to subtract things from 180? Yes. Was there any reason any of you couldn't do that question? No. The reason, if you didn't do it, was you chose not to do it, right? And is that okay? Of course it is. It's your work. If you chose not to do that question, and I put that question on a test, you were choosing to give up 5 marks, right? As long as you accept that, I'm happy. Because there's no possible way for me to teach you everything, is there? I cannot show you an example of every single use of trigonometry and graphing and everything in the world. That's impossible. All I can do is give you an example, or is give you the tools you need to solve the problem. If we were in a carpentry program, would I have to show you how to use a screwdriver on every single kind of screw ever invented? No. What would I show you? Here's a screwdriver, here's a screw. Righty-tighty, lefty-loosey. This one has a square thing. Go get the one that fits in. This one has an X thing. Go get the one that fits. This one's flat. Go get the one that fits. This one's got a star. Go get the one that fits. This one's got a hex. Go get the one that fixes it. Would I actually get out all 18 million kinds of screws and screwdrivers and show you? Or would I get one, the best, Robertson, and show you once, righty-tighty, lefty-loosey? That is what I would do. Whose responsibility is it then to learn how to screw in every other kind of screw? Yours, because it's exactly the same thing, right? There is nothing new there. Therefore, every one of you should have been able to do that question, right? It takes work. I know that work, for most of you, is like one of the 7 dirty words you're not allowed to say on television. Work's like yet another 4-letter word. That's okay. It's fine with me. I do not care. But when you see questions like that show up on a test, you don't get to complain that you don't know how to do it, because you do know how to do it, right? All right. Any other questions? And I specifically warned you yesterday when I assigned this, don't waste all your time on those super easy ones on the first page, did I? I said spend some time with the hard ones at the end. Everybody good? All right. So I am done. You have this page, page 182 to 184. It is a worksheet. It will be marked. When will it be marked? Tomorrow. You have, I don't know, some time right now. I'm in such a good mood, you might have some time tomorrow, but I would not bank on it. Understand what I'm saying? Good. You have the cos law, you have the sine law. When do you use sine law? As long as you have a pair of side and angle, you can do sine law. What do I mean by pair? Do I mean this? Do I mean that? Is that a pair? No. Is that a pair? Do I have a pair there? Yes. Can I do sine law there? Not yet. Why? Or can I? Can I do sine law on that? Of course I can, because I have that side. So I have a theta there. I can sine law that. That will give me my third theta, which will allow me to sine law that. When do I use cos law? Every other time. Okay? Okay. Who loves coleslaw? I love coleslaw. I actually don't. I don't like coleslaw at all. But I don't mind coleslaw. My dog scratched my wrist climbing on the couch yesterday. It's already seeming to get infected. And now I'm going to have to put a hockey glove on it. I may lose my hand. True story. Hockey players often, well, not often, but every so often get flesh-eating disease from infected cuts in their disgusting hockey gloves. Same with rugby players. The hooker for Canada nearly lost his leg. Yes. Why wouldn't I play? I'm a comedian. The whole point. Just look at my YouTube. It says right on it. Category, comedy.
That's true.
I'm a comedian. Why wouldn't I go do that? It's funny. Yes. I don't mean to be funny on the ice. I'm just a bad hockey player.